Alrighty, race fans, welcome to another edition of the Workbench. Well, today we're going to be taking a look at some new tools, and it's not from Hardin Creek Slot Cars, this is from Viper Scale Racing. So what we have here is a Endbell pre-seating tool, and these are fascinating parts. They're not the first ones on the market. As much as I know, I think years ago I was the first one to actually come up with something for this problem. The issue with the motor brushes in these Endbells is when they manufacture these things, they're not pre-arced to the circumference of the commutator. They're flat. Now, you ask, why don't they do that? Well, these brushes in all these products are somewhat repurposed from other applications. I mean, they're making these things overseas probably by the millions per day for all kinds of motors, and the engineers believe that this is what they want. They want a flat brush so it has more life, and for what their applications are, they're not looking for absolute high speed. We're looking for absolute high speed as quick as we can get it. So, probably a couple of decades ago, some of the guys in Hopper or whatever figured out how to do this, and they were basically just taking a mandrel and running it in a knurling tool on a lathe, and just putting a knurl into the soft steel and then using that. This idea of a diamond mandrel, I'm not exactly sure where I got that, but I did figure it out. The very first tool, this is a remnants of one, I found some diamond mandrels that were approximately the right diameter on the diamond coated end, and I took short axle pieces and press them onto one of these armature collars that's on the back of an armature, and then glued that onto the front of this thing. Now, if you were gentle, it worked, but if you dropped it, it would break that piece off or something. But it was just hinky, guys. But nonetheless, it was one of the first ones on the market, and they sold pretty well. After a couple of production runs of these, I had a company take the same diamond mandrel and face it off, because you've got this is a hard tip piece of steel and it's encrusted with diamond, and then they had to face that off and then put a hole in the middle of it and then pop the axle in, and it's probably friction fit. They might have put a little super glue or something, and these work real good. The problem was it took probably 6 or 8 months to get the company to make me probably maybe 100 of them. I forgot how many I ordered, but it was really, really costly. And I think I was selling these for $30 a piece. I didn't make hardly much money on it at all, but here again, it was an important tool for guys to have. And once I ran out, I kind of had enough of this. The company, it's good company, but it was not anywhere near their core business. Maybe lack of better descriptions, they did large contracts and things like that, so something like this just didn't fit. So I gave up on trying to get more of them made. Now, here recently, Dan's cracked the code on this. He found some company somewhere, maybe here, there, yonder, I don't know where, but he got diamond mandrels, same thing, and had the end of them machined out or drilled out, and then put a pilot in it. They come in two flavors essentially. You've got a fine and you've got a coarse. Probably the fine is maybe around a 200 grit, and the coarse might be around 100. So you kind of ask, why would you need both of these? Well, kind of to back up, before any of this was probably ever done, what guys would do is build their cars and stick it on a little break-in box at 5 volts for so many hours or whatever, and just let the natural friction of the commutator, arc the brushes out. And once again, you'd have to do all this ahead of time before you got to a race to make sure your cars were in absolute tip-top shape. So it was a process, but now we've got the ability to kind of short-circuit that, and these are a couple that I've already done here, and maybe I can kind of show you. Once you're done with this thing, you might be able to see a little bit of a arc right in there. It's hard to kind of tell, but relative to a brand new one that's perfectly flat, you really short circuit this break-in process. So what I've found with these tools here, and this is the way you do this, I would not learn to do this under power. I mean, you can chuck it up in a Dremel and stick it in there, but you might not have much brushes left because these things cut quick. So what you do, get yourself your little Endbell or your Endbell spreading tool, okay? And we're going to start with the coarse one, right? Get that thing in there just like that, and then twist it back and forth. 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11, 12. Okay, not much more than that. Just twist it back and forth. Right. So then you come along with your fine tool. Do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, thereabouts. And if you get a magnifier then and look at the amount of surface that you cut on that brush, it'll probably be around 70 to 80% of the surface is cut. That's all you need. You don't, if you go 100%, you're probably taking a little advanced life out of the brushes. There's no really need to do that. And then at this point, maybe blow the dust out, build the car, and then break it in for a little bit. It won't take much, 5-10 minutes just to smooth it out. That's it, and go racing. So it really does work. Now, you can probably get by with either tool, coarse or the fine. If you decide to go with just the coarse, you'll probably need a little bit more break-in time once you run the car, but even then you'll get speed right away. The fine, if you are doing a lot of these things, what I've noticed, even like on my original tool with the fine, is because it's a fine coarse, it will load up with the carbon dust, okay, and the effectiveness of it kind of goes away. So you'll have to clean it off. You have to get some silly putty or something and roll that around on the silly putty. Let me get some of it right here. Roll it around in some silly putty to kind of get the carbon out of the pores of the cutter. So if you do both of these, coarse and a fine, you'll get most of your cutting with the coarse one, and because it is coarse, it has a tendency to probably not load up as much, and then you would go back and do it with the fine to kind of get some of those coarse radial tool marks out of it. But I'm really excited about this. I believe retail on these is $29.95, just around $30, and I'll have them listed on the website here pretty shortly. And got any questions, give me a call or send me an email. Alrighty guys, thank you very much.